Look, it's a bird! It's a plane!
It's a dinosaur?
Dinosaurs roamed the Earth for more than 135 million years. That was over 65 million years ago during the Jurassic and Cretaceous eras. There were so many of them in different shapes and sizes. Some were as small as a chicken, and others were larger than the average house. There were semi-aquatic types, bipeds, and quadrupeds, just to name a few. The dinosaurs were the ruling animal life form of their era. But that was about to change.
Hello ladies and gentlemen, boys and girls, pets and infants. Today we are going to talk about how birds as we know them are related to dinosaurs. So birds are believed to be related to theropods, which are a diverse group of dinosaurs. Theropod means beast-footed, so if you want an image to meet the term beast-footed, think of a velociraptor or a Tyrannosaurus rex, or T-Rex, both of which are theropods. As I said before, theropods are believed to be related to birds. So if birds exist now, why don't the dinosaurs? Well, a bunch of evidence supports the theory that a huge asteroid ended all dinosaurs' life. This asteroid, which was about 10 kilometers in diameter, hit just off the coast of where Mexico is now and left a 180-kilometer crater. The impact released 420 zettajoules, or 420 to the 21 joules of energy. That's 6.25 trillion times more energy released than Little Boy, the bomb that was dropped on Hiroshima. The collision made a huge dust cloud that blocked out the sun, killing plants because they can't photosynthesize, which led to herbivores dying to the lack of food, which led to the carnivores dying due to the lack of food, and then basically no oxygen existed for life to go on.
Shortly after 1860, after Charles Darwin's release of An Origin of Species, a German researcher discovered an elaborate fossil encased in limestone. This fossil was Archaeopteryx lithographica, more commonly known as Ervogel. Ervogel, meaning original bird, was the first example of a transitional form, a link between two vertebrate groups. After this first piece of evidence, support slowly grew for there to be a link between birds and dinosaurs. During the 19th and 20th centuries, Thomas Henry Huxley, A. Walker, and G. Heilmann's hypotheses drew the public's attention to this phenomenon even more. This was only further supported by J. H. Ostrom's description of Deinonychus anteropus, which showed the great similarities between Ervogel in 1969. Then, in the 1980s, Dr. Gautier's cladistic work seemed to be the final push for there to be a tie between birds and dinosaurs. Many have tried to disprove this theory, but evidence for it far outweighs anything naysayers have been able to come up with. In fact, the line between bird and non-avian dinosaur has only become increasingly blurred.
And now let's go to the field.
There are many structural and skeletal similarities between modern birds and their ancestors, the theropod dinosaurs. One notable similarity between them is how they have hollow bones. The bones still contain bone marrow. If they didn't, birds would not be alive today, but there are definite air pockets inside the marrow and bones. It is true that these hollow bones contribute to the weight reduction strategy, as well as being part of a breathing apparatus in the bodies of these creatures, because flying is a very high energy activity. Also in the bone structure area of similarities is the fact that their clavicles, also known as the collarbone, is fused to form a furcula, commonly known as a wishbone. Birds and theropod dinosaurs have very similar foot structure and a bipedal stance. One of the most solid pieces of evidence found, though, is the discovery of feathered dinosaurs in China. These dinosaurs were believed to have protofeathers, commonly known as first feathers. These feathers were asymmetrical, which is very important to flight. They belong to the clade known as coelosaurs, which includes a group of theropods that are more closely related to the birds than the carnosaurs. Archaeopteryx was around when the dinosaurs were, but some scientists think that that lineage dead-ended. It was the clade, Ornithomorpha, that branched off to form the modern birds. As you can see, there are many similarities between birds and dinosaurs.
Wow, isn't that pretty neat? So in conclusion, today we learned how dinosaurs and birds have structural similarities, how ginormous the meteorite was that ended the dinosaurs, and how the theory developed between dinosaurs and birds. So, just remember, kidlets, the next time you look out of your window, you could be looking at a dinosaur. Oh my goodness!
I wonder if it's going to do it again.
Fuck you, science.
We'll talk about behind the scenes.
Bala, bala.